Akash is preparing for DRDO Scientist B and he has prepared the subject data structures and algorithms. So let's start your snap. What is dynamic programming and algorithms?
Programming is like greedy, divide, conquer, and there is a dynamic. This is algorithm approach by which we can give a optimized solution by building some optimal substructure. And in dynamic algorithm, there is every sub divide into some sub problems, and every sub problems are uniquely counted, and it is stored in some places, and that's why it is gives us the optimal solution. This is dynamic algorithm.
And you said greedy algorithm. So what is the difference between greedy and dynamic?
GD always the best when GD gives the best result in maximum profit, minimum weight, like minimum cost, like that. Means there is a we take always the best case in greedy approach, but in dynamic approach we take the optimal solution. That in optimal solution that may give us the best solution, best case, but greedy is always we are greedy about the something profit like cost. That's why. That's the greedy. Maximum reliability. That's the difference, main
Dynamic
difference between.
programming doesn't take best solution.
No, sometimes. No, dynamic. No, dynamic to always give you the optimal solution. But greedy sometimes takes the best solution, but sometimes give you the not the best case always. As you take the most suitable case, most profitable case. That's why somehow you miss something. But dynamic always give you the best case solution.
Okay, can you tell one example where dynamic programming doesn't performs good but greedy performs well?
Okay, suppose um, knapsack in knapsack problem, if you take the 0 1 knapsack, fractional knapsack. In fractional knapsack, uh, if we go through the greedy algorithm, it will give us the best case. But in 0 1 knapsack, in fractional knapsack, dynamic program is mm, not take too much time to do. But in 0 1 knapsack, greedy algorithm may not give us the actual solution. A 0 1 knapsack in dynamic program gives us the optimal solution.
So how much time will greedy take in 0 1 knapsack?
In 0 1 knapsack, in login,
Greedy will take in 0 1 knapsack, solving 0 1 knapsack problem.
yes, in login.
Okay, and how much time dynamic programming will take fractional knapsack problem solving?
It is take n into s, n into 8. N is the number of uh, entity in the year, and W is the weight of the knapsack. So
Okay, are you
suppose
sure it is n log n is actually less than W into S, what you said?
this depends. If W is more, then n log n is best because it is depend in the weight in NW. It is always depends on the weight, but in log n it is depends on the number of elements, and we do the
Then
mass
how
per
can
time.
you say that dynamic programming takes more time? I think DD takes less time in both the cases, 0 1 and fractional.
As it is depend on W, if it is weight is more, so it can take more time na? In dynamic programming 0 1 knapsack, a fractional knapsack.
Okay, any other example of greedy you can give?
And VD is better than dynamic.
No, sim only greedy you can give, no problem.
Oh, only it is lot of problem. Like this, like that. 0 1 knapsack, optimal mass pattern, Hubman decoding.
Okay, what is Huffman coding?
Hubman coding is a prefix code. Like suppose there are four items and it is occurs in like that. A is more, B is second highest, third is second, and C D is fourth. So we always take the minimum element from this and merge these two in a greedy approach. Like that, suppose we have to take an example and do this. A, B, C, D, four things. Suppose four this. Okay. So first one is 100 and second one is 80, C is 70 and D is 10. So we take the minimum two from this and merge it. Okay. So first it is C and D, we merge it, and uh, then we take the next minimum, it is B, and we merge it, and then A. So A is the maximum time occurs. So we try to assign the A is the race B. Suppose 0 or 1. Then B is second race, then it is 1 0. And C is 1 1 1 0. And D is 1 1 1. This way we can
Okay.
assign
So
prefix code to the. Hmm.
which data structure is used in this?
It's WinHit.
Hmm?
WinHit.
What? Can you repeat?
Oh, in Hoffman,
Yes,
it is master.
merge sort.
And we
I'm
use
asking
the
about
sorting algorithm.
data structure. Data structure. Which data structure
Oh, okay, okay.
is this Huffman
Just
coding implemented?
this priority queue,
Okay, what is a
I
priority
think.
queue?
This is priority queue generally two types. It is like ascending or descending. So when we give a output, input, any order, and it is output as a minimum element and second minimum, it is ascending. And the descending is if you give input and the output we get like first maximum, then descending order, so it is descending. Those two types of priority.
Okay, and what is the
This
difference
case we
between a
use it.
priority queue and heap? You heard the
Priority
question, right?
queue.
What is the difference
Yes,
between
yes,
and
yes.
priority queue and
Let
heap?
me let me think of it. Can I take time, na?
Yeah.
On priority queue, suppose for finding any element, we always take if the size of the queue is n, always take n element. Okay. To delete n element, it is time complexity is order of n square. Suppose. But for uh, mm, if
Whose time
mini for
complexity
max is
is n square?
n square for queue, suppose you have to traverse the total queue to find the minimum element for priority queue, and I
Okay,
don't
my
know the
simple question is what is okay. You
answer.
don't know
I
the
have not.
difference, right? Okay,
It
what is the time complexity of Huffman?
n log n.
N log n. Okay. And this has been implemented through priority queue, correct?
Yes.
Okay. And the fractional knapsack which you told, which data structures has been used into that?
It's also same. This is the same phenomena in both n log n time also.
Okay. Okay. Do you know what is a graph?
Yes. Graph is a function which is built with the vertices and edges. It may be connected, may be disconnected, with anything. Maybe there is between a edge. Like this.
Okay. And how do you traverse a graph?
Traversing is visited the every node of the graph. It traverse.
Any graph traversal techniques you remember?
Yes, it is two types of depth first traversal and depth first traversal.
Okay. What is the difference between the two?
or breadth traversal, it is traverse around the level wise. Means suppose in first level you start from one node and the second level uh, it is all in the second level all is traversed in the third level. It is a breadth wise it is traversal and it is using implemented using queue. For depth first traversal, it is wise from starting from a node, it is totally depth wise, it is traversal. The traversal is by stack. That's the main difference from this.
Okay. Breadth first traversal is by stack, right?
Queue,
DFS is by queue, and
BFS,
breadth
BFS, BFS, breadth
BFS
first
is
traversal is queue.
hmm, and DFS is DFS uses which data structure?
Breadth first traversal, no?
Hmm.
Are you asking breadth first traversal? Queue.
Breadth first traversal uses queue, and depth
Yes.
first traversal uses.
Sure.
In both the cases, it is queue.
No, depth first traversal it is using stack because it is implemented likewise. Depth first traversal first suppose a node, then adjacent we can take one stack wise. Then if it is stack is full, then we have to pop it. Anything there is no visited array inside. All the array, oh sorry, all the nodes adjacent to in DFS is visited. Then we have to pop it and go backtrack. So that's why DFS needs stack and DFS needs queue because it is
Suppose
level.
some graph is there, which complete graph it is, and that is having the vertex 5. Number of vertices are 5. Okay. So what will be the total number of possible spanning trees you can make?
Is complete.
Yes, it is complete.
So n to the power n minus 2, 5 q 125.
Oh, okay, Akash. So let's move to the feedback. So I think most of the things you told were correct only. One or two places you got confused that what is the difference between priority queue and heap. Both are actually the same things only. Priority queue is implemented either as a min heap or as the max heap. Okay. There
Yes.
is like
Yes.
very slight difference, but it won't matter. Like both are the same things. You can consider them as same. Fine. And dynamic programming. Yeah.
Actually, my previous interview feedback only problem is that if you don't know anything, don't say. I don't think any risk from giving the answer.
Ah,
If any,
if you don't know, just don't make the answers like that. Okay. If you don't know, just say no. If you have little bit idea, you can say, I know
uh,
this, but I'm not very sure.
I can
Okay.
ask them, na, okay, this is this, after this, then I can proceed. If we don't know,
You
but
can
we
say
know
that
something.
according to me, this, it should happen, but I'm
Okay.
not very sure. You can say like that.
I can ask them na, any question if it is like a clue type like hint. I want to confirm them that okay, it is this. I can ask them also. There is no problem in that.
Like asking in the sense I'm not able to understand.
Asking in the sense, suppose okay, ma'am, this is I am going through this way. Is this the correct way? I can ask them also, like in some pseudo code part or like that. Either
If
giving
you
the
will
wrong
ask
answer.
like this, they will
Hmm.
say like, okay, you can try. Okay, they won't answer your questions.
Okay.
Okay, so there, I don't feel personally that you should ask any question like that.
Okay.
Okay,
Okay.
you can ask the question if they say that if you want to ask something, then only ask. And they won't answer in any case. Probably they will say you can try and tell. So
Okay.
you can explain your approach, what you want to do or you are doing, or after doing you can tell. But this it's not a great idea to ask questions. Okay.
Okay.
Okay. You want to
This-
ask anything else?
Okay. Okay. Ma'am, is the over? Then just stop the record.
What?
You can stop the recording if I ask some doubt or.
Okay. Okay.